how close you come to the end of your lab report, which is actually really pretty good. It's just a measure of how close you come to a known value. So, for example, here's the formula. The experimental value, this is what you get in the lab. I'll say your lab value. And then the actual value, let's say you were trying to find the density of a substance. That you can look up that substance and find the density on a table or something. And so that would be what's called the actual or the accepted. I would say the accepted value, and you would look that up and maybe cite that source. So let's just look at an example of an actual lab calculation that one of my students did. So let's say you are finding the density of a piece of copper and you got 8.78, and then you look up the value in a table, maybe in your textbook or something, and you found it was 8.92. That's really pretty close. So let's look at this formula. So the experimental value, that's your value, goes first, and then we'd subtract the actual value. Now, if you look at those two numbers, do you notice I'm going to get a negative number when I subtract? So that's why we actually use absolute value in that subtraction there. That way, it doesn't really matter if you're positive or negative, over or under. How close are you? And then we divide by the actual times 100. Okay, so the difference, we would do that first. That would be 0.14, and then that's divided by 8.92 times 100, and that would give us 1.6% error, which is actually really how close do you have to get to the actual value? That just depends on the nature of the lab, how many times you did the lab, the equipment that you had. So it's just going to vary from lab to lab. Anyway, that is how you calculate percent error.